G'day, it's Rusty from Rusty's Outback Adventures, and welcome to part 4 in our Goodbye Camper Hello Caravan series. And in this video we're going to tackle the 12-volt electrical system, which the Caravan back in 1986 didn't really have a lot of. From what I've been able to see so far is in the 2 dome lights in the roof, there's a 240-volt globe and a 12-volt globe, and I'm suspecting the 12-volt globe actually worked from the trailer plugged into the car, even though someone has fitted an aftermarket battery and a fuse panel just to run the water pump. So what I'm going to show you today is all the gear that we're going to be putting into the van. And right at the front here I've got 3 of these Renogy 100-watt solar panels, and they will be connected together in parallel with some cables which I've got somewhere. And they're going to be fitted to a aluminium framed rack that goes on the roof. I've got to be mindful that the weight on the roof, because the roof is a pop top on the van. So these 3 will be connected in parallel, give me 300 watts of solar power, coming in through a 25 amp DC-DC charger, and that'll be connected to, obviously, to the car through an Anderson plug down to the back of the Navara, and that'll provide power while I'm driving, and then once we're off grid we can use the solar panels. This bad boy, this is what's going in for my battery. This is a 200 amp hour lithium battery from Custom Lithium. I went with Custom Lithium because they offered a slimline style of battery, and that's what I wanted because of the space I've got. That cupboard, I'll show you where the electrical system is going to be fitted, and in the cupboard all the electrical gear will go in there, but this is actually going to go under the bed because it's not going to fit anywhere else. But basically, by going 200 amp hour lithium, I've sort of like future-proofed the Caravan, because I'm going to also be running, and with this I've also bought their battery monitor, so I can monitor the state of charge, because if you're not familiar with lithium, and I'm new to it, lithium batteries state of charge isn't dependent on their voltage. What normally happens is, with an AGM style of battery, which I'm used to in the past, and that's what the camper trailer had, when they're fully charged they show about 12.8, 12.9 volts, and as the voltage comes down their state of charge is equally coming down. So by the time you get to 12.05 volts, that's 50%, and they don't really like to discharge an AGM past 50% of battery. But whereas the lithium, you can take them right down to 20% charge, but you need to monitor the state of charge because the voltage is quite a constant value until it drops off. So hence the battery monitor. Along the way we've also got some panel meters, and these panel meters I've used in the Navara as well, and they are the Hall effect coil style. So you pass the cable through here, you connect, you pass the cable through the coil, the tail connects to the meter, and I'm going to have 3 of these. I'm going to be reading the solar charge coming in. I'm also going to be monitoring the current draw, and I'm also going to be monitoring the output from the DC-DC charger. Along the way I'm also going to be using these manual reset circuit breakers. Now I like these, maybe a little bit of overkill, but I like this style, and I've used them in the Navara as well. A couple of switch panels. Now these switch panels are going to be for things like turning the pump on and off of the water pump, some lights, because I'm going to run lights underneath the shelving that's part of the van, and I've got 2 of those. I may not use 2 of them at the moment, but I've got 2 sets of 4. The other thing I've got here are these multi-outlet USB connectors, which is a 1 amp and a 2.1 amp, and also a couple of cigarette outlets. So I've got 4 of them, and they're going to be throughout the van. And what I will do is I'll make a panel to fit on the side face of the cupboard where the electrical equipment will be installed. So it'll be nice and neat and out of the way, and the battery will be mounted, as I said, under the bed. So I've also got this 1200 watt KickAss inverter. Nice thing about these is they also have a panel on the front so you can see what's going on, but they also offer a remote panel as well, so I can mount this I can mount the inverter in the cupboard somewhere and then have a panel that I can see from a distance. So I've got this panel that I'll be able to review to see what's going on in terms of how much it's putting out, and be able to turn it on and off. And it also has I think it's a 5 or 7 meter length of interface cable that runs between the plug on the side of this and the remote panel. So that's the last piece of the jigsaw puzzle to go in the electrical system. And the main reason for the inverter is so I can charge my drone batteries, my camera batteries, my laptop as well, and it just gives me 1200 is more than enough probably. Gives me a little bit of room in the future if I needed to charge anything or run anything a bit bigger. So that's the reason I went to 1200. I just thought I'd show you guys what the 200 amp hour slimline lithium battery weighs, and I just plop it on the scale now, and you can see it weighed 20 kilos. Now, to put that in perspective, a 100 amp hour AGM battery typically weighs around 29 to 30 kilos. So I'd need 2 of them to give me 200 amp hours. So that's 60 kilos. I'm running a 20 kilo battery. The weight saving is enormous. I'll show you in the van now where the electrical system will go, and show you where the major components will be laid out in the van. As part of the electrical system upgrade, I did talk before about replacing the fridge. Now this is a 240 and gas fridge. Now because I'm only running one 9 kilo gas bottle on the drawbar, I think it's probably beneficial to take this fridge out, and we'll run a 240 and 12 volt DC fridge. So until I can get this one out and measure the size of the opening, I'm not sure what I'm going to put in, but I'm sort of tossing up between the Bushman and the angle uprights. But once I get this one out, I'll know for sure what I can squeeze in there. So I've got to disconnect some pipe work and work out how to get the screws out, and so I'll get on with that. And now the fridge is out, I know what I'm working with in terms of what dimensions I've got to deal with. I've also noticed too, you can see this, just turn that down a bit. This wood looks like chipboard. It's pretty rotten, so I'm going to have to replace that piece before I put anything back in here. Yeah, it's pretty ordinary looking bit of chipboard, so I'll replace that with a bit of marine ply. And as I said, I'll just go and check the sizes of the various fridges I'm looking at and just see what I can fit in there. And I've removed that chipboard shelf that had got all wet and rotten, and I've cleaned it all out. So what I'll do now is I'll measure this up, and I'll put a piece of marine ply in here, and that'll give me a basis to put the fridge on. And I've gone with the Bushman DC85X, which is an 85 litre fridge. It has a little freezer in the top. Thank you, little freezer. And the door can pivot both ways, and I will have to change it around because the way it fits in the van, I want the door to open the other way. What you do get as well, and the main reason I went with this particular fridge, there are other brands offering similar sizes, was the hole that's the original hole in the cupboard where the original fridge was. I didn't really want to go cutting it to make it fit. So what I've done is I've gone for a fridge that's slightly smaller than the opening, and I'll put a fascia around it. You get these mounting kit assembly, which, if I can get this the right way round, so it bolts onto the side somewhere here, and then you can butt it up against a fascia. So I'll do that, and I'll swap the door around, and I'll size it up in the hole and see how it fits. Well, I've replaced that rotten piece of chipboard with a piece of 9mm marine ply, and what I did too was I've trial fitted the fridge, had to put a little timber rail up here, and when I measured it all, I actually had enough room to put a shelf. So I've got this little shelf in here. Rather than trying to just put some sort of fascia board, I thought, why don't I make a shelf? Let you into a secret. My mate Reese said to me, put a shelf in there. So thanks, Reese. We come up with that over a beer last night. So I've put a rail in underneath, I've put a shelf in, and I've trial fit the fridge, and it fits really, really nice. So I'll just put the fridge in one more time. Hopefully that's the last time I've got to put it in, and I'll just show you how it fits. And that's the fridge sitting in place. And as I mentioned earlier, I swapped the hinge around. So being in the kitchen, you can open the fridge. So when it's closed, I've now got this that fitted quite nicely here. Just that shelf up top gives me a little bit of storage. I'll probably put just a basket or something, slide in so nothing can fall out over the back. Yeah, really pleased with the progress. So next we got to continue with the electrical system. Well, I've stripped the shelves out of the cupboard, and I've got this piece of 18mm marine ply, and that is going to be the board that I'm going to mount all my electrics on. And I've decided the battery will live in here too. These, the beauty of the lithium batteries is you can stand them on their end, and it's going to take up a lot of this room here, but I will get all the components on the board, and I'll just show you how that board layout looks on the bench. So I've laid the components out on the board, and I'll just run through what I've got. So the batteries here on the bottom, I've got a fuse panel with its own circuit breaker. I've got a circuit breaker for the battery for the distribution post. I've got a negative distribution post as well. The DC-DC charger fits here on the side, and we've got a circuit breaker for the solar in, the alternator in, and the charger out. And then on top here I've got the 1200 watt inverter, and over here there's a circuit breaker feeding that, trying to keep this close to the battery, which it will be. And that's sort of how I'm going to do it. What I don't want to do is start drilling holes and then change my mind and go, I should have put that there. So I'm pretty confident this is how it's going to look, and once I've ticked off in my head where it's going to go, I'll then be able to attach all these items to the board and then start wiring it up. Not sure if you can see, there's a pencil line here, there's a pencil mark here, and one up here, and that denotes where the battens are at the back that this board will screw to. So I need to be mindful of being able to screw this whole board onto the rails in the cupboard. So I think I've got everything where I want it. It's just now a matter of ticking it off in my head, really. But that's the progress I've got to so far. And all good projects need a wiring diagram. And as you can see here, this is mine. Basically it shows solar input up here, and I'll have an auxiliary solar Anderson plug on the van. We've got an Anderson plug coming in here, which is feed from the car into the DC-DC charger, circuit breaker here, and I'm also measuring the solar current coming in. The output from the DC-DC charger ultimately ends up going down to the power link, the distribution link with a circuit breaker, and I'm also measuring what the charger's putting out. Now I've also got a circuit breaker coming off the distribution board, off the distribution post, goes up to the fuse panel, and then the KickAss, the inverter over here, has its own circuit breaker. What I have noticed too is with that lithium battery monitor, it has the ability to measure the current being drawn, so via the shunt, so I don't need to run another meter. So I'm only going to use 2 of those panel meters, the Hall effect ones, and the third one will be the battery monitor and also show me the current draw. So this is my diagram, very similar to the one I used in the Navara, and yeah, with the components laid out on the board, I'll just finally decide everything is where it needs to be, and then I'll get on and wire it up. Well, after I pre-wired the electrical panel on the bench, I've had to take it apart again in order to put these mounting screws in here. So the inverter sits up here. Oh, it's a bit bright. Down here is the battery, and I've got some cable entry points on the side, some down the bottom here, down the bottom, and one in here. So, and I've also got 4 entry points coming in through here for underneath. So now the panel is in securely, I now put the inverter back up here, I can put the battery in here, Yeah, so I'll just show you the clamps I made in order to hold the battery in place. Now to mount the battery in place, as I mentioned, I made these aluminium straps. I'll just take one off here. So it's just a piece of 50 by 3 aluminium flat bar, and I've bent it in my press brake attachment I've got on my 30-ton press. So it just makes it easier, makes it a nice bend here rather than putting it in a vise and trying to bend it here with a hammer. So that's the straps I'm going to use. I've just got to secure them in place, and then that'll hold the battery nice and firm. And same, I've installed the inverter again, and I've screwed that down so it's nice and tight as well. So the next thing to do is I've got this bit of space in my hand here, which is actually the front side of this panel. So I'm going to cut an opening in here, and I'm going to install an aluminium panel that'll have the meters in it, a couple of switches, and a couple of cigarette outlets here. And in the bottom of the door, bottom of this cupboard door down here, I've got a grate. I've got a grill to go in here, get some airflow in. And if I need to, I can put a fan in this bottom side here of this panel here. So I need to get on there and mount that battery, work out how big the plate's going to be, make this aluminium plate to go in this front fascia, and I'm getting very close to being able to tick the box that says the electrical system's done. Now I've measured that area on the front of the cupboard to put the little panel with the meters in it, and what I've done is I've just transposed those dimensions onto my bench here, and as you can see, the outside white line is the total size of the panel I can have, and this inside white line is basically the room I've got between the timber frames inside the cupboard. So what I've got here, this is the panel meter for the solar input to tell me how much is coming into the DC-DC charger. This is my battery monitor for the lithium 200 amp hour battery. Now it also measures current going in as well as current going out. So that's why I don't need that second meter to measure what the charger is putting out to the battery, because this will do that for me. And then I'm going to put this 4-gang row of switches in the panel as well, and then this is the 2 cigarette outlets and the USB. So what I'm going to do now is transpose this onto a drawing. We'll take it to the plasma table. As I said, my twin brother Rusty, who runs Rusty's Metal Cut Signs and Designs, is going to cut me a piece of aluminium with these fascia, cut it with the cutouts to suit these meters and this switch panel and here. So I'll get that done, we'll get it drawn up, I'll show you the drawing, we'll cut it, and then we'll be able to mount these and get it in that cupboard. Now this is the file I created for the electrical panel. I've got cutouts here for the solar current meter, I've got the cutout here for the battery monitor, this is here for the switch panel, and I'm going to run those cigarette outlets and USB in a vertical configuration, and I just cut 4 little holes for the corner. Now this panel's 239mm wide, 287 high, and that fits in with that panel on the cupboard. So that's the file. And if we open up the software, we're going to cut this with. Rusty's not here today, so I've ducked over and stolen his plasma table. So this is the panel we want. We're just going to size it correctly. It's 239 across the X, 39. Now what we're going to do is rotate it, because I'm going to cut it on a piece of alley that's the way it's located on the table, and I'll click OK. I've just got to line up the torch and tell it where it is. I'll just show you what I've got on the table here. So we've got this sheet of 3mm aluminium on the plasma table. We've lined the torch up, so it's going to start in this bottom corner. Just trying to use an offcut, and as you can see on here, I've rotated the design sideways to make it fit in there. We've told the torch it's down here, which is in that bottom corner, and as long as I dial it in correctly, we're just going to choose 3mm aluminium, 3mm alley plate. Alright, just set the cutter to 41 amps, the air's on, set the cutter to 41 is there, Okay, we're set to go, and I will hit the start button, and the torch will come over and cut the hole. And just like that, we've got ourselves a panel. I want to come out. Come on, there you go. Alright, so there's our electrical panel. I'll just clean it up and we'll see how all those meters and switch panel and everything fits in there. Alright, and here's our panel. We've got our switches across the bottom, our 2 SIGE outlets and a USB. And this is the monitor for the battery, which will give us state of charge, current draw, a few other nice things which I've still got to read the book about. And this is our solar input current meter. So that tells me what the solar panels are putting into the DC-DC charger. I'll just show you in here. And in the cupboard here, it's, where are we? Yep, fairly tight for room. I've got room for connections to put on the back of the meters, wire up the switches, wire up these outlets here. This is pretty much good to go. I've got a couple of cables still to connect to the battery. Yeah, I'm getting very close. Got to run some cables, one for the fridge, which is next door, and some other outlets around the place, and I'm good to go. So we're getting very close to turning this power on and having a look at it. Well, I've connected everything up. I've still got a few loose wires to tidy up here and there in the cabinet. Around here, I've powered it up. I'm very pleased that it's working. It's a bit bright. The fridge is working, as you can see by the lights on in the fridge. Now this, oh, I can take this little plastic bit off the meter now. Alright, so the panel meter, I haven't calibrated it yet. I need to tell it some values, but you can see the battery's showing 12.2 volts, 3.7 amps. That'll be the fridge running. At the moment it's got 78% battery, but as I said, I've got to calibrate this and enter some values which I need to go through the menu. This meter here will be my solar input. I've got to run that cable underneath from the external Anderson plug, which is an auxiliary to run portable panels, because there's other set of panels going on the roof. They're not on there yet. I'm running out of time before I head off on Friday. These are my SIG outlets and my USB. Down here we've got 4-gang switch. What I've done is I've split these. Standard switches come with a positive in and a negative, and they loop them all across. What I've done is I've separated these switches into 2 banks. So I've got these 2 operate off of 1 fuse, these 2 operate off another fuse. So down here, so I've split them here, so I've run separate fuses for each half of there. There's the clamp holding the battery in. This is the interface unit. Oop, and you can see that. This is the interface module that talks to the shunt. So this negative shunt here, all the negatives come back to one side. I've got a distribution block here. All the negatives come to one side of the shunt, and then it goes to the battery. This unit talks to the shunt, which now talks to my panel meter, and it tells me current in, current out, all that sort of thing. So at the moment all these other circuits are off, but yeah, I'm very pleased that I've got this far. And as I said, I'm running out of time, but yeah, I'm happy that I've got this far. Now I've got to do now is just run a few more cables, wire a few more things in, and we can just about tick the electrical box off. So I just thought I'd give the inverter a quick test. What I've done is I've plugged in my soldering iron. There's my little electric soldering iron. And I'll just run through these menu functions here. So we've got 13 volts on the battery going in, putting 240 volts out. It's output 0.18 of an amp. The output watts is 43, and on the side of the soldering iron it says 48, so that's pretty close. 50 hertz is the frequency, and just around here I've just turned the fridge. There's nothing else running at the moment, so this panel meter is showing 4.9 amps is what the inverter is drawing from the system to run to make my soldering iron work. So yeah, there's my soldering iron down there. I'll just show you what it said on the side. Yeah, 48 watts, 240, 50 hertz, 48 watts. So that inverter's running. That's not drawing much, but I just tested it to make sure it works, and I'm really happy with that. So I can just turn that off now. Yeah, one more thing tested. I'm pleased that the inverter's doing its job well. Now I've hooked up the solar input Anderson plug under the van, which is a chance to use the portable solar panels if I need to top up the ones on the roof. Well, currently the ones on the roof aren't there, so I'm just testing the system at the moment. Now this panel, as I mentioned, this panel here is the solar input current, and it's doing 5 amps at the moment. This is the battery monitor, and we're seeing, it's jumping around a bit. The sun, it's a bit cloudy at the moment, so it's showing me here that I got that going in 8.8 amps at the moment. And around here in the panel we've got a, I'm not sure if you can see this. This unit here is a Redarc BCDC1225D, and this is a lithium battery, as I mentioned. Now the profile is Li, and the reason it's Li is because I've joined the green and the orange wire together, which is what I'm supposed to do. And if you can see here, it says it's on solar, and the stage is solid red, and the solid red means bulk charging the battery. So I'll just show you outside what I've got set up out here. Now, so as you can see, it's sort of sunny. I've got a solar panel out here, which is one of the portable ones I take away. I usually take 2 of these 200 watt folding panels, and I'll just show you under the van. Sorry about the mess in the shed. There's shit stuff everywhere at the moment. And under here, oh, you can see that. Where's my hand? There. There's a Anderson plug runs up through the floor. It's sort of temporary at the moment. I'm not quite sure how I'm going to run it, so at the moment I've just put it in there. So with the solar done, tested, the only thing I need to do now is to test the alternator input, and I'll check the alternator input once I bring the car over again. So right now I'm really pleased with, sorry about that light on the panel, I'm really pleased with the progress. Pretty much got the electrical system ticked off, and that's really pleasing because, like I said, I've got a fair bit to do before I go. So after reading the manual for the battery monitor unit, you can see now that this is 97% of state of charge, and the amp hours remaining is 195.96. So what you do in the menu is you scroll through the menu and you tell it what it's, just do it here. So in here, this amp hour preset is 200 because it's a 200 amp hour battery, and when it's fully charged you then tell it that the amp hour remaining value is 100%. So it'll then work backwards from there. So during the course of using power on the system and then the charging, you can then determine how much power you've got left in your battery based on the state of charge. So that's the electrical system completed now. I'm pleased with what I've got done, and I said another box ticked in order to get going and take this Caravan out for the first time. Well, that's it for the electrical system upgrade, and I'm really pleased with the way it's all come out. The big thing for me was the lithium battery we put in it. I thought that was the way to go. And I'd just like to say a big thank you to Ben from Custom Lithium in Queensland. Ben answered quite a few of my questions I had before I actually went with them to buy the battery and the battery monitor. And yeah, I'd just like to thank him for that. And I'm not sponsored by anybody, but I used his product, and I shout out to Ben. And I'm sure there'll probably be a few things I need to do. One job I never got done was the solar panels on the roof, so we'll do that in a later video. So that's it for this one. So if you like the video, a thumbs up would be appreciated. If there's something you don't like about the video and you give it a thumbs down, I'd appreciate you putting in the comments what it was you didn't like, because I'm always trying to learn how to make better content. In the description below, I'll put a list of the electrical components that I used to build the system. So if you'd like to subscribe to the channel, subscribe button will be down here. And if you haven't seen the other videos in the series to date, I'll put a link to the playlist up here somewhere, and you can check that out. So that's it for this video, and I look forward to seeing you in the next one.